Which of the following is equivalent to x cubed minus 3x squared minus 2x plus 9 equals negative 2x cubed plus 3x squared minus 1? So this one, we're just going to combine like terms. And normally to solve these, you would always want it to equal to 0. So we're going to put everything on one side here. I'm going to bring it from the right over to the left. So we're going to add a 2x cubed, subtract a 3x squared, and add 1. So that'll cancel all those out. And the easy way is to just go ahead and line them up with whatever term that they will be combined with. So the cubed x we'll put here. Then we got minus 3x squared. We don't have any x to the first power. And plus 1. So okay, all that goes away and we get equals 0. And over here, x cubed plus 2x cubed, that gives us 3x cubes, negative 3x squared minus 3x squared. That gives us 6 negatives x squareds minus 2x. And 9 plus 1 is 10. And there you go. That's your answer. In the triangle, side AB equals 2 radical 3, and cosine of A equals radical 3 over 2. What is the length of side AC? Alright, so this is a right triangle, so we're going to be able to use sine, cosine, and tangent on here. And if you remember your SOHCAHTOA, cosine equals the adjacent angle over the hypotenuse. So the cosine of A, this is A. All right, it's the adjacent side, 2 radical 3 over the hypotenuse. All right, so we're going to have 2 radical 3 over x. We'll let AC be x. That's what we're trying to find. Okay. And they already told us the cosine of A equals that. And to explain that a little better, is they already told us what the cosine of this equaled, but we didn't know this. So we already have the answer, and then that's how you would get that. So I put it into a proportion there, and then we can just solve that. We'll cross multiply here. Radical 3x equals 4 radical 3. Divide both sides by radical 3. Okay, those cancel out. So we get x equals 4. All right. It's just a little geometry, a little trigonometry for you. But yeah, there you go. Which of the following numbers serves to disprove the statement, every number which is a factor of a prime number is itself a prime number? 1, 2, 4, 7, or 25? This is one of those questions on the SAT that I feel they always put on there just to try to trick you. because I doubt in all of your math classes you ever had a teacher that explicitly would have told you this. Which of these numbers doesn't have factors that are also prime numbers? Well, first of all, 25 and 4 aren't even prime numbers. So we can get rid of those. And alright, we're looking for something that'll disprove that statement. So, well, the factors of 2 are 2 and 1. Factors of 7 are, not 2, 7 and 1. Well, that would fit. However, 1 only has one factor. 1. So here's a really, really fun math fact. 1 actually isn't even a prime number. So boom. The answer to this question is 1. Don't let them try to trick you on a question like this. A conservation team wishes to plant 600 new trees this year in local parks. With 6 months remaining in the year, the team is planning to raise the average number of trees planted per month to 72. After reviewing the plan, it's discovered that even with the increase, the team will still fall short of its goal by 6 trees. What was the team's average number of trees planted per month during the first 6 months of the year? Well, alright. This problem sure has a bunch of word salad in it. And it's also one of those problems that has numbers we don't need. Like, we don't need to know that they needed to get 600 total trees. Why? Because they didn't get to 600 trees. How many did they get to? They fell 6 trees short. Well, so they got to 594. That's how many trees they got. And they did 72 the last 6 months. Well, okay, so let's just see what they got those last 6 months. 72 times 6. $432. Okay. So they did 432 in the last 6 months. So let's take 594, subtract 432. We're going to get 2, 6, 162. So, okay. They planted 162 trees the first 6 months of the year. So how are we going to figure that out? Well, just divide by 6. And let's do a little long division here. 2. So, 27. There you go. They planted 27 trees the first 6 months. So see, maybe if they weren't such big of slackers the first 6 months, they would have got to their goal of 600 trees. But no, they didn't do it. At what value of x does the graph of the linear equation 7y minus 6x equal negative 5 cross the x-axis? Alright, so hopefully this is going to be one of the easier problems for you. It's just finding an intercept. So if we're finding like the x-intercept, what you would do is substitute 0 in for y and vice versa if you wanted to get the y-intercept. So okay, they wanted you to find the x-intercept on this one. So we're gonna see what happens when y is 0. Because see, that's gonna be the ordered pair. So we got 7 times 0 minus 6x is negative 5. Okay, 7 times 0, well, that's gone. Negative 6x equals negative 5. Divide both sides by negative 6. And you got x equals 5 over 6. There you go. That is the x-intercept. Hey everyone, look out for all my other math tutorials here on Divide by Zero.